Hi, this is Brett Sackett with Pasco Scientific. Today I'm here with
JJ Plank.
All right, and so what we're going to do is we're going to take a look at the new wireless force acceleration sensor, and this is our newest wireless sensor in Pasco's new line of wireless sensors. And this one is going to allow us to measure plus or minus 50 newtons of force. It also has a built-in 3-axis accelerometer, which is going to give us the ability to measure X, Y, and Z components of acceleration, as well as the magnitude of the resultant. And there's also an internal gyro sensor, so we can get angular velocities around X, Y, and Z axes. So let's look at the accessories, JJ.
Cool. All right, so in the box, there's a few little things that come with it. First is a USB charging cable here. The wireless force acceleration sensor has a rechargeable battery inside of it. We can use this USB cable to connect it to a computer or a power source to help keep that battery charged. Two of the smaller accessories, a rubber bumper and a metal hook, both mount to the front of the sensor, the front of the force sensor. And the last is this long thumb screw that we can use to mount the wireless force acceleration sensor to the top of a Pasco Dynamics card, just like that.
All right, well, let's power it up and let's see what the data looks like. I'm going to turn on the wireless force acceleration sensor here. There's a button, and this button powers up the sensor. You'll also notice this port here is the USB port that you use to keep the sensor charged. And we can also use this for data collection. And when you're collecting data using the USB port, you can achieve faster sampling rates.
Okay, great. So I'm using Pasco Capstone software right now, but the wireless force acceleration sensor will work with SparkView software. In Pasco Capstone, there is a list of all of our wireless devices, and they use a low energy Bluetooth 4.0, which lets us connect them within the application. A single click there on the sensor in the list, and it connects it to the software, and we can use it to collect data just like we can in the other sensor.
All right, and so we're going to power up this second force sensor here the same way, and JJ's going to connect that. And what we're going to do today is we're going to look at the forces between these two sensors. We're going to couple them with a rubber band, and we're going to look at Newton's third law.
All right, great. So it's important to note that the measurements the force sensor makes are directional. Some are positive, some are negative. And if we have the two force sensors facing each other like this, we want to change the sign on one of them. So positives in the same direction and negatives in the same direction.
So JJ is going to change the sign on one of these force sensors. And you'll notice on the force sensor there is a coordinate axis. And this tells you which direction is positive for X, Y, and Z.
All right, so I'm going to bring up a graph here, and I'm going to put the force sensors into this graph. They're going to be plotted along the same axis there. And now, another thing that we want to do is we want to zero the sensors, and we're going to do that in the software. And all we need to do is just make sure we have the right sensor selected, and then we'll click that little zero button.
All right, so while JJ is zeroing those sensors, I'm going to take this rubber band now and connect the force sensors up, and I think we're ready.
We're ready. Let me go ahead and click start here. Grab that guy.
All right, and we're going to pull these sensors apart from each other, and you can see that the forces are equal and opposite.
Very cool.
That's some good physics right there. All right, well, thanks for watching. If you have any more questions about the wireless Pasco force acceleration sensor, go to www.pasco.com.